equal to 0. When we say f, we've got f at x. F at x is our y. So once you start saying f at 0, that means it's where x is equal to 0. So when you look here, x is equal to 0 only on the y-axis. So when the graph cuts the y-axis, we call that point the y-intercept, which means this point will be our y-intercept. This will be our y-intercept. F at 0 is the y-intercept. This is our y-intercept. That's the first point we need to find when you are to sketch a cubic function, right? We've got f at negative 2 is equal to 5. F at negative 3 is equal to 0. F at negative 2 is equal to a number. F at negative 3 is equal to 0. F is our y. When do we let y to be 0? We let y to be 0 for x-intercept. For x-intercept, we let y to be 0, which means f at negative 3 will be our y-intercept. Oh, let's write it here. And it will be our x-intercept. This is our x-intercept because we have let y to be 0 to find the value of x. F at negative 3 equals 0. This is the x-intercept. Right. F at 1 is equal to 1. It's equal to a number. F at negative 2 is equal to 5. This is the gradient. The gradient at negative 2 is equal to the gradient at positive 1, which is equal to 0. For our gradient to be equal to 0, remember, you need to have a horizontal line. So for our gradient to be 0, we need to have a horizontal line. We need to have a horizontal line for the gradient to be 0. So which means this is the turning point. At the turning point, the gradient is 0. The gradient of that line, because it's a horizontal line. The gradient is 0 here, since it's a turning point. This gradient, when you look, is equal to that gradient, simply because the two lines are horizontal lines, which means they are parallel to one another. That's the reason why we say this. The gradient at negative 2, which means the gradient where x is equal to negative 2, will be the same as the gradient where x is equal to 1. That gradient is at the turning point because the gradient at the turning point is 0, which means these values inside there, those values of x are the x values at the stationary point. X is equal to negative 2 or x is equal to 1. These are the x values at the turning point. X values at the turning point. X values at the turning point. Let's check now if they've used same values of x somewhere. F at negative 2. F at negative 2. The gradient at negative 2. F at negative 2. When do we use the x value at the turning point? We use the x value at the turning point to find the y value by substituting into the original. This is the original, it's f. So to find the y value at the stationary point, substitute the x value into the original equation to find the y value, which means the y value at the turning point, if x is equal to 5, is equal to -2, y will be 5. Therefore, let us write our stationary points there. We've got -2 is to 5, as you can see there. Again, this is our x-intercept. Let's check if they've used 1 again. X is equal to 1 here. So substitute the x value into the original. Let's check. This is the original. So which means if x is equal to 1, y also will be equal to 1. So the other turning point, it's 1 is to 1. Let's draw the graph. Let's draw the graph. Cartesian. Let's draw the Cartesian plane. Right, that's our Cartesian plane. It's x here, it's y there. That's the origin. Right, let's start with the x and y intercept. Our y-intercept is at 3. Let's say we have 3 there. Let's say we have 3 there. Our x, we've got only one x-intercept. Only one x-intercept, this one here. -3 is to 0. -3 is to 0. Let's put -3 here. Right, we've got our turning points. -2 is to 5. -2 is to 5. Let's say we've got 5 up there. Right, -2 is to 5. -2 is to 5. Right, -2 is to 5. Right, 1 is to 1. 1 is to 1. So the point is here. So those are our points. Remember, this is the turning point of an increasing function, obvious. So This is the turning point. That's the turning point. This is the function of f. Our turning point is -2:5. And then the other turning point here will be 1:1. It's 1:1. And then we've got the y-intercept, which is 0:3. X-intercept here, -3:0. So that's how our graph will be looking like. It's an increasing function with only one x-intercept, So that's how it will be looking like. And then let's stop here. And then we are going to move on and try to do some other examples on different types of questions.